Well, good morning and welcome to the Raypak Digital Swimming Pool Heater Installation Webinar. We're going to be taking about an hour to talk about the proper installation of this gas burning appliance. My name is Brad Duncan. I am a trainer and product specialist with Raypak. As a reminder to all of our participants, the instruction provided in this training is intended for qualified and experienced professionals. If you're not qualified, please do not attempt to apply these instructions on your own. Now, this is the Raypak Digital Low NOx Swimming Pool Heater. We're talking about the Low NOx model today. So Low NOx devices use a fan-induced combustion, thereby reducing emissions of nitrogen oxides. Local and state codes in California, Texas, and Utah require these appliances for various applications. Properly installed and maintained, this heater will provide your customer with many years of reliable performance. The low NOx sizes mirror the sizes available in the atmospheric model. The BTU input is the same. You will notice that the model sizes end in a 7 instead of a 6. One way you'll know a low NOx from the atmospheric models is this air intake on the right side of the cabinet. This is where the fan pulls in combustion air. Make sure this intake always remains unobstructed. Often people will store things near the heater. It's generally a bad idea, but especially if the stored items block the air from getting into the heater. Here's what the low NOx looks like with the door off. Take you for a little tour here. We're certified for combustible flooring. You can set this thing right down on a wooden floor if you need to. Up top on the right, you'll notice a dual tap 24-volt transformer. That's inside of a junction box on the right there. This particular appliance pulls 6 amps at 120 volts or 3 amps at 240 volts. If that junction box is not appropriate for you, that is to say, if you want to pull the conduit up on the left instead of the right, there's an identical junction box on the on the left-hand side. You'll notice that it has pre-drilled holes in it. That's to mount your transformer if you should need to. So if you want to pull the conduit up on the left, you would take your transformer out on the right, 2 screws holding that in. Take that out, disconnect the wires, reinstall it on the left, and pull the wires back accordingly. You will notice there is another object in that junction box. That's our fan relay. Don't worry, there's still room in there for the transformer. I've moved transformers many times on the low NOx appliance. No problem at all. Heat barrier here keeps the heat downstairs where it belongs. Here's our pilot assembly located in a slightly different location if you're accustomed to the atmospheric model. This would be our air pressure switch. That is a proving switch so that the heater knows if the fan is turning at an appropriate speed. Over here you have our rollout sensor. This is the fan. This again pulls air in from the right-hand side. There's a vent on the side of the cabinet. That pulls combustion air and pushes it into the plenum here, this air box. At the same time, the gas valve will open and release gas into a manifold that is located inside that plenum. From there, those 2 elements of fuel are pushed into the burners where they mix and come out the top to ignite. Down at the bottom, you'll notice there is a flame viewport. This particular model has a bit of a bulkhead there that seals off the flame from view. We've had to put a flame viewport there so that you can make sure, if necessary, if the pilot is lit properly. And of course, our bonding lug attaches here on the lower right-hand corner of the cabinet. This heater, and indeed any gas burning appliance, has certain requirements for proper operation. You need proper water flow rates, gas flow rates, combustion air, electrical input, correct ventilation, and more. If you install it wrong, it won't work right. A large percentage of the failure rates we see can be attributed to substandard installation. A properly installed heater works better and lasts longer, and that keeps your customers happy. We're going to break the installation down by topic here. So we'll go with water, air, gas, and electrical. I'm going to start with water because that's why we're here. We're in a water industry. After positioning the heater in its permanent location, you'll plumb the incoming water line from the filter to the left side port. There's an arrow at the top of the inlet, so you don't forget. Don't plumb it backwards. In on the left, out on the right. In order to achieve maximum performance, the rate of water flow through the heater should be within parameters. Minimum rate varies by model. All models max out at 100 gallons per minute. If your system is moving more water than that, we strongly suggest using an external bypass to divert some of that water around the heater. Or if you're using a variable speed pump, you can make adjustments necessary at the pump to the programming in order to maintain water flow within these parameters. Without a flow meter, you really don't know how much water is running through the heater. There are many types on the market. You choose the one you like. Just make sure it is installed according to the manufacturer's specifications on how and where to install it. Now here's one example of a manual bypass. It's basically just a pipe that runs between the inlet and outlet pipes that allows water to bypass the heater. How much water bypasses can be controlled by a valve on the bypass. You might also choose to install isolation valves on the heater side of the bypass. This would allow the circulation system to function in the event of damage or service to the heater. If you close those isolation valves, you could remove the heater and still operate the pool system. Your flow meter should be positioned between the bypass and the heater. Now, putting it elsewhere might only tell you the flow rate on the system and not the flow rate on the heater. So you want to put them here, either coming or going. I like to put them on the influence side just to make sure I'm not going to have any issues with the heat from the water causing a problem with the flow meter. But again, in this position, you can see it's between the bypass and the heater. Now, here's another configuration for a bypass. If you use this one, the ball valve is on the main line. So in order to push any water at all through the heater, that valve would have to be at least partially closed. Wide open means no water is going through the heater. Completely closed means all the water is flowing through the heater. And again, positioning of the flow meter is important. There are many factors that can influence rate of flow, but the pump is the most important. If you're working with a variable speed pump, flow rates can be adjusted from there. Just make sure that all programs fall within acceptable flow rates. Bear in mind that at the lower end of the parameters, you might find a flow point at which the heater pressure switch will still close, but there's not quite enough water running through the exchanger to cool the tubes sufficiently. So then the high limit switches get tripped and shut the heater down. During setup, run the heater with the pump at the lowest speed programmed for 10 or 15 minutes to make sure this doesn't happen. And then do that same test with the plumbing set to spa. Remember, the hydraulics are different on the spa. So if you've got a pool spa combo, flip those valves around, let the pump run and the heater run in spa mode for 10 minutes or so just to make sure we're not going to have a problem. This is our pressure relief valve. The National Fuel Gas Code requires a pressure relief valve if you have anything downstream of the heater that might restrict flow. The code specifically uses the word nozzles at one point. I would think that eyeball fittings in the plaster could be considered nozzles. The PRV is provided with the ASME model in order to meet ASME compliance. but we don't provide one with the polymer residential model. We do provide a port for installation in case you need to install one. We're going to leave that up to you. That port has a threaded plug that can be removed with a 1/2-inch drive socket wrench. For safety, piping should be installed after the PRV and oriented downward, terminating around 6 inches from the floor or as required by local code. Avoid using PVC for this, as heat transference can warp PVC pipe. Every effort should be made to ensure that plumbing is as straight as possible, using as few turns as possible. Sweep 90s are far less flow restrictive than hard 90s, so use those as much as you can. Restrictive plumbing affects everything in the system. Your chlorinator might not work as well. The pump uses more energy to move the water. Reduced flow means longer turnover times and slower filtration. Increased pressure on the system could slow the water to the heater, reducing pressure at the header and causing premature shutdown. Take a look at this. This is a clean filter. Okay, that elevated tank pressure is due to plumbing restrictions. Take a look at the hard street 90s going into the backwash valve. Okay, very restrictive. So shorter filter cycles means more pressure nuisance shutoffs. This loss of flow causes the pressure switch to open and shuts the heater down. The pressure switch is there to ensure that there is water flowing through the heater. Typically, the heater will operate safely when there's enough flow to generate 1.75 psi. That's where the switch is set at the factory. This, of course, assumes that the heater is installed at or near the water level. Up to about 5 feet or above or below the water surface, you can adjust the pressure switch as necessary to require more or less pressure to close. If you're installing 5 or more feet below the water surface, you'll need to install either a higher rated pressure switch, which we do have available from Raypak, or a flow switch. We do offer a flow switch as well. There are a number of them on the market. Raypak has one. If you are 5 feet above the surface, only the flow switch will work. Let me tell you why that is. Let me grab my little laser pointer here. So if you're down here below the water surface, remember the water is coming downward through the pipes. Those pipes hold enough water to generate enough pressure just from the gravity to close the pressure switch. So you would either, as you begin to install below the water surface, you can adjust that pressure switch to require more pressure. You can do that up to about 5 feet. After that, you've maxed out the pressure switch, and you'd have to go with either a heavier duty pressure switch or a flow switch. If you're up here, on the other hand, pressure switch isn't going to do you any good, because the water traveling downward from the heater back down to the pool, that water is also being acted upon by gravity. It's being pulled downward. And in fact, it could be pulled downward at a rate that offsets the pressure, so that there could be zero pressure up here at the heater, or negative pressure for that matter. At that point, a pressure switch isn't going to do you any good. You would need to put a flow switch on here to alleviate that problem. Here's an example of where a flow switch might come in handy. The weight of the water in the pipes could easily create enough pressure to close the pressure switch. If the pump fails, the heater won't know that, because it still has good pressure. So the heater can dry fire, and you will damage that heater. Turning this adjustment wheel clockwise will cause it to require more pressure to close, as might be necessary when the heater is located below water level. Which of course means that turning it counterclockwise causes it to require less pressure to close, like for an elevated installation. All right. I don't see any questions on the board, so I'm just going to keep rolling. We're going to talk about air. When we talk about air, we're mostly talking about indoor installation, but there are some safety issues involved with outdoor installation that have to be addressed. Per National Fuel Gas Code, the point from where the flue gases exit the heater must be at least 4 feet below or horizontal to any door, window, or inlet to a structure. If it's closer than that, the point of exit must be at least 1 foot above. So 4 feet below or horizontally, or 1 foot above any door, window, or inlet. That means if you have a heater anywhere within 4 feet of this window, 4 feet out, 4 feet below, 4 feet to either side, then the top of that heater or the exit point for the flue gases must be 1 foot above the door, window, or inlet. Now, those guidelines apply unless you have an opening that is a forced air inlet that actively draws air in. Then the flue gas exit point must be 10 feet below or horizontal to, or 3 feet above. This is all for safety so that you don't expose people within the structure to noxious fumes. By the way, these guidelines are NFGC stuff. This is for gas appliances in general. It's not a Raypak thing. This applies to any heater that you might be installing. Indoor installation has certain requirements for air. The heater needs both combustion and ventilation air. You can't have a fire without air. That air must be provided through an opening at the bottom of the wall, down there where it says combustion opening. All right, so as the heater burns, hot exhaust is created, which is vented from the room through a vent duct. The gases rise by convection, creating a pull or a draft. Now, this creates negative pressure within the vent, causing combustion air to be pulled in too quickly and disrupting the flame, causing problems. The most notable problem would be soot. All right, we can fix that. To relieve the negative pressure, an indoor stack kit must be included with any indoor installation that comprises a draft hood or a vent hood and the ancillary products necessary to install that hood. So now we have a vent hood. This allows relief air to be pulled in without disrupting the flame below. So now we have the same thing going on. We got air coming up, okay? Hot fumes are going up through that pipe, creating a draft. Only now that negative pressure, that draft begins to pull air in from underneath the hood and not underneath the heater, okay? So we fixed that problem, but we created a brand new one. In this configuration, that draft hood, when the heater's running, starts to suck the air out of the room. It's pulling air out of that room like a vacuum cleaner. We have to replace that air. Replacement air comes in through a ventilation opening at the top of the wall. That is our ventilation opening for ventilation air, sometimes referred to as replacement air. So the NFGC has guidelines for this. All right, those are dictated by the National Fuel Gas Code. So what they're saying is you need 1 square inch for every 4,000 BTUs, commencing within 12 inches of the floor and 12 inches of the ceiling. So 2 holes in the wall, 1 at the top, 1 at the bottom. As an example, if you've got a 407, 407 would be a low NOx product, so that's what we're talking about today. That's a 400,000 BTU product. 400,000 divided by 4,000 equals 100 square inches. That's a 10 by 10 hole, 1 at the top, 1 at the bottom. So here's the thing about those holes. It's very rare to see these ventilation openings that are just open to the elements. They're usually either covered by louvers or screens or both. All right, those louvers and screens will restrict airflow. So if you have louvers or screens, you would add 50% to the size of that opening. You now have a 10 by 15 hole. If they're louvered and screened, you would add another 50% to the size of that opening. You would now need a 10 by 20 hole. 2 of them, one at the top, one at the bottom. All right? 2 things to bear in mind here. First of all, in this example, we have 1 heater in the room. What if you have 2 heaters? What if you got 1 for the pool, 1 for the spa? What if you got 2 heaters and a hot water heater or a boiler that's also in the room, or 2 boilers? You have to account for all of the BTUs in the room. So you would add the rating plate input, BTU input for all of those devices, add those all together, and make sure that the holes are sized accordingly. All right. If you're installing a heater in a room with a fan that pulls air into the room, that's called forced air ventilation. Generally, you would need an HVAC technician to determine if the fan pulls in enough air to accommodate the gas burning appliances in the room. If you are tuning in today from Texas, the ASME models in Texas have to be low NOx. All right, so you may come across this sort of thing. They require not just any old HVAC guy. You would need a ventilation specialist for that. All right, and they would have to sign off on the room. Forced air ventilation. If you're installing a heater, often you'll find a swimming pool equipment that's installed inside a structure or a shed. Whether you're installing it in that way or whether after the equipment was installed, someone built the shed around it, doesn't matter. That's now an indoor installation. That's going to require a vent hood and correctly sized air intake openings, not only for the sake of proper performance, but for safety. We don't want anyone using this small space to suffer from inhalation of fumes. As the flue gases travel through the vent, they begin to cool. If they get below 132 before they get out of the vent, condensation begins to form, and the resulting condensate not only rusts the galvanized pipe, but because it's very acidic, it can damage other parts of the heater if it runs back down. So it's important to get the gases out of the flue vent before they cool below 132. We want to avoid anything that would slow them down. Anything like, say, oversized venting. If the gases have room to expand horizontally, then they won't move as quickly vertically. We want the gases moving upward, steadily, and quickly. Undersized venting also a problem. If the vent is just too small to accommodate the gases being produced, they won't get out of their own way. This leads to internal condensation as well as other issues like rollout and sooting. Now here's some problem venting. First of all, it's downsized, which is a problem, but look at the horizontal portions. You know, convection pulls the hot gases upward, not sideways. Hot air rises, so there's nothing to pull the fumes horizontally. You can use horizontal venting, provided that the rise is 1/4 inch per foot. So for every 4 feet of horizontal vent, the downstream end must be at least 1 inch higher than the other end. This way, the flue gases always have an upward path to travel. There may be installations where, because of the length of the run or other factors, the heater can't be sufficiently vented without help. The help is the D2 power vent. You can think of the D2 as a pump for heater fumes. The flue gases are now forced out through a smaller 4-inch duct. This means you now have a positive vent pressure, and your venting must now be category 3 stainless steel with sealed seams from the D2 all the way to the termination point. That means you can't just run the D2 and put this 4-inch vent up to the hole in the ceiling where the vent normally would be. You can, however, use that existing vent as a chase to run the 4-inch vent inside of. Okay, there are 4 part numbers for the D2 because there are 2 physical sizes, and each physical size will come available 120 or 240. So one physical size for the 2 smaller sized heaters, one size for the 2 larger sized heaters, and each of those 2 sizes is available 120 or 240. If you can't get the voltage you need, you can change the voltage in the field, fairly easy operation, but it still has to be the right size. Let's move on to gas. These are the gas line requirements. The larger the heater size and the further the distance from the regulator, the larger the pipe diameter must be. You can't expect to deliver enough gas to a 400,000 BTU heater using 50 feet of 1-inch pipe. The pipe's just not big enough to move enough volume. This is just physics. Okay, again, not a Raypak thing. This is a physics thing. You will find that these distances and sizes are similar across all heater manufacturers as they are related to NFGC guidelines. You may find that the size of the heater will be dictated by the gas pipe. It's just barely possible that the client will not want to dig up their entire backyard to accommodate a new heater. All right. Now you can try a smaller sized heater, or depending on circumstances like codes in your area, things like that, you might be able to increase the pressure in the pipe and then regulate back down using a second regulator at the heater end to convert that pressure to volume at a pressure that's appropriate for gas valve, for the gas valve that is on the heater. This is that secondary regulator, but that should be outside the cabinet. It's equipped with a pressure vent that can release gas into the cabinet, which could ignite. Also, this gas cock should be outside the cabinet where a user can find it and shut off the gas in an emergency. All right. NFGC does require one of those, but it's supposed to be within 6 feet of the heater, but it should be, again, on the outside where it can be easily found by anyone who might be looking for that sort of thing. The use of a flexible gas line is also not recommended. They are restrictive, they are noisy, and the right size is rarely used. Most people just use a 3/4 inch, and that very likely is not going to be big enough to accommodate the rate of flow, to accommodate the volume that you would need. Let me show you what I'm talking about. ANSI standards indicate what sizes of corrugated steel tubing you can use. Most people, again, just use the 3/4 inch, okay? But 3/4 inch is only going to accommodate up to 114,000 BTUs. Okay, we don't even make a gas burning heater that small. So now you could upgrade up to that 1.25 inch. That would accommodate up to 430,000 BTUs. That'll cover this appliance. But bear in mind, that thing's going to be a lot more expensive. It's going to be a lot less flexible. You know, that little, 1/4 inch, 3/4 inch, whatever you got, you whip that thing around like a toy. All right. At 1.25 inch, it's going to be a lot harder to bend. It's going to be a lot less flexible for tight turns. It's just going to be less convenient. We're going to recommend using rigid pipe right up to the gas valve. This is a sediment trap. They are mandated by the National Fuel Gas Code to be used on every installation. Sediment and dirt can be pushed along by the flow of gas inside the pipe, and the idea is to capture that sediment before it gets to the gas valve. The sediment can start to accumulate inside that gas valve and cause it to fail, and those gas valves aren't cheap, okay? It's important that the gas be traveling downward and then turn toward the heater just before the trap. This way you have gravity and momentum working together to capture the traveling sediment. The gas valve is designed to accept pressures within a certain range. The gas leaving the valve on the way to the burners will exit at a set pressure. If the incoming range is correct, the outgoing range will be also. So upon installation, check these pressures with a manometer. Here's the thing, man. I know a lot of guys, they just, hey, I'm replacing a 400,000 BTU heater with another 400,000 BTU heater. I'm sure it'll be fine. Will it? Is it going to be fine? Is it just possible that maybe a problem with proper gas flow is what caused the old heater to fail in the first place? Check it when you install it. At least you'll know it was right that day. Okay. And again, those are your pressures. Now, again, we're looking at the low NOx model today. So 5 to 10.5 coming in, and you're going to get 3.1 on the other side. If you plan to install or work on a gas burning pool heater, you should have a manometer. This device measures pressure acting upon a column of water. The increments are in inches of water column, and there's just under 28 inches of water column to 1 pound PSI. Okay, so we're only talking about small amounts of pressure here. That pressure is just there to drive the volume of gas. There are 3 main types of manometers available. The slack tube manometer on the left is the standard. It actually has water in it for the gas to push upon. In the center is the dial type. It's spring-loaded, works much like the pressure gauge on a filter tank. On the right is the digital type. They are considerably more expensive, but they measure in much smaller increments. As you can see, this one measures down to 1/100th of an inch water column. A far smaller increment than you would need on a device of this nature. Choose the one that you find appropriate. They should all come with tubing to complete the distance from the test port to the manometer and a fitting to adapt the hose to the test port. The test ports are located on the gas valve, one on the supply side, one on the manifold side. The Allen wrench necessary for removing the plugs are often included with the manometer. If they are not, or if it is not, then you're going to make sure you have a 3/16 inch Allen wrench in your toolbox. That's pretty standard across most, not only most swimming pool heaters, most gas burning appliances of this nature will have similar test ports at a similar size. There are 3 measurements to be taken. The first is the static pressure. This is taken before the valve without flow. This is just the pressure of the gas standing on the pipe. This is like testing the air in your tires. Just same thing. Okay, we're just checking the pressure on the pipe. Leave your manometer in place and fire your heater. That will give you the dynamic pressure taken before the valve with flow. So this is the pressure while the heater is burning. Finally, you'll cap that back up and move your manometer to the test port on the right in order to take the manifold pressure. This is taken with flow after the valve. This is the pressure of the gas that's going to the burners. The idea being, if you have the right pressures coming in, you'll have the right pressure going out. And remember, the heater might run with incorrect pressures, but you will develop problems over time. Check the pressures upon installation. And again, here's your pressure guidelines. All right, let's move on to electrical. Again, we're burning gas to create heat, but we need electricity to operate the heater and power the electronics and the gas valve. Like most pool heaters, we need 24 volts AC. Since there's no 24-volt AC plug in the wall, we'll need to create that 24 volts using the power that's available. We'll accomplish that using a step-down transformer. Okay, on the low NOx model, the fan runs at high voltage, either 120 or 240, depending on what you have there on the property. But the electronics and the gas valve still operate on 24 volts AC. During installation, the transformer is wired to the incoming voltage, 120 or 240. After wiring, no further action is needed to accommodate voltage. There's no plugs, there's no wire harness, There's no clips, you know, 120, 240, white for this, red for that, black for this. None of that exists on this particular heater. Once you've wired it up, you're done. You're ready to go. Okay, straight from the box, the transformer wires will be sticking out the side of the cabinet, and there'll be a red sheet of paper attached to that with wiring instructions on it. There are 3 wires on the primary side of the transformer, white, red, and black. On the secondary side, that's the 24-volt side, there is a blue and a yellow. There's also a green ground wire that attaches to a ground screw on the cabinet. You're going to be wiring on the primary side only upon installation. The other side, secondary side, is already wired. Whether you're wiring 120 or 240, the ground is the same, so you might as well wire that up first. All right. If you're wiring 240, okay, we don't need the white wire. White wire is a neutral. We don't need that on a 240 line, so we're going to go ahead and cap that off. Your remaining 2 wires are your hots. So you've got 2 wires coming out of the transformer and 2 wires coming out of the conduit. One of those hot wires goes to the red. The other one goes to the black. And of course, as you probably already know, it's unlikely that you're actually going to see a red wire and a black wire. That's NEC color coding, but most often it's just two blacks or 2 reds. If you get them both, hey, that's great, but ultimately you just need to remember that one hot goes to red and one goes to black. Now, if we're wiring 120, well, now we need that white wire. That's our neutral, okay? So that means one of the other 2 wires is you will not need, okay? And that wire would be the red. So we'll cap the red. We will connect up the white to the white wire coming from the sub panel. And the remaining wire is our hot, and we will connect that to our black coming from the transformer. Wired properly, you'll have 24 to 29 volts coming out the other side and plugged into the board. Now, since we're talking about the Low NOx model today, I would point out that the fan runs full power. So that has to be connected to the power source before the transformer. The fan runs through a relay, which is wired with the transformer. Both the relay and the transformer have the same 3 wires in the same colors. Each colored pair is already twisted together at the factory. So you just treat those 2 wires as if they are one and wire accordingly. So there's no difference in wiring the Low NOx model. You just have an extra wire of the same color. Check the voltage at the installation point to verify that it's in range. Occasionally, you may find the voltage on your 240 line to actually be 208. This most likely means you have 3-phase electrical, often found at commercial buildings. Do not wire the heater for 240 operation if the incoming voltage is 208. All right. Remember, low voltage in means low voltage out. Now, one solution to this problem is to wire the heater for 120. So on a 3-phase system, each of those 2 hot wires are still 120 volts each. If you pull in a neutral wire, you can cap off one of your 120s and use the other for the hot leg of your 120 circuit. Okay, so we've pulled in a neutral, we've capped one of the hots. We now have a hot, a ground, and a neutral. That's a 120 circuit. Now we can wire the heater 120 instead of 240. Now, your other option would be to wire in a different transformer that accommodates 208 volts. If you choose this option, just be aware that it could potentially affect your warranty. Guys, these 208 transformers are pretty readily available. They're not hard to find online, and in fact, many of them are really quite inexpensive. I've seen them for $8 or $9. Not sure how much I would trust a $9 transformer. In fact, if you read some of the comments, some of the reviews of these products, you'll find that they quite often fail relatively quickly. Okay, If they should happen to fail and damage the heater in the process, we may not be able to warranty that, okay? We're going to try to get in the hole with you as best we can, but if you're modifying the heater with substandard parts, we may have a little problem with that. Let's talk about remote operation. I get a lot of questions about that. Your modern operation systems, or automation systems rather, will have their own dry contactor on board. That would be a dry contactor for the heater. They will also have their own water temperature sensor that's not attached to the heater at all. They all work the same way. They monitor the water temperature on their own, and when heat is necessary, they close a contactor, okay? That's all they do. That's all they know. Your automation system doesn't know what a swimming pool heater is, doesn't have a clue. All it knows how to do is close a contactor, and the heater takes it from there. So here's an example. Here's the temp sensor for the automation system. Here's the contactor up here, okay? So it amounts to putting one wire to one side of that contactor and one wire to the other side. On the board next to that 5-amp fuse, you'll find our dedicated remote circuit. It's a wire harness with 3 wires and a label for identification. The blue wire is the hot. That's going to be live with 24 volts when the board is powered up. The other 2 wires, an orange-black and a black-orange, will determine whether the heater turns on in pool or spa mode. So, blue's hot. You'll need a length of wire to span the distance from the heater to the automation system with at least 2 conductors. Blue wire, again, is hot, so we're going to extend and attach that wire to one side of the heater contactor on the remote. Choose one of the other 2 remaining wires, it doesn't matter which, extend and attach that to the other side of the contactor. So if the return wire is connected to the orange-black at that P8 position on the board, when the contactor closes, the heater will turn on in spa mode, which means if you use the black-orange, when the contactor closes, the heater turns on in pool mode. Now, it doesn't matter which one you use because pool and spa mode are no longer important. Those are labels for the heater. All we're looking to do is turn the heater on full blast and let the automation system to decide when to turn it on or off. All right, so we've wired it up. Now we need to tell the heater to pay attention to the automation system. So first we'll set the temperatures for the pool and the spa all the way up to 104. This fully enables the heater so that it doesn't get in the way of the remote. All right. Now using the mode button, we will select the off mode of operation. Then press and hold both the up and down arrows simultaneously for 5 seconds to enable the remote function. The heater is now a follower of the automation system, and it will begin its firing cycle when that contactor closes. These are the minimum clearances for this heater. These clearances should be maintained to prevent damage or combustion of nearby surfaces and to facilitate maintenance and repair. Again, these are the minimums. In some cases, more is better. On the water side, for instance, you could use more than 12 inches if you can get it. The front of the heater needs at least 24 inches just to get the burner tray out. And again, more if you can. Remember, the front of the heater is where you're operating the heater. Failure to maintain clearances makes the heater difficult to work on and can certainly cause damage to other nearby surfaces. I'd like to take a moment to state Raypak's commitment to developing and producing sustainable products. Raypak and our parent company, Rheem, have established firm goals as we work towards substantial reductions in waste, both in our manufacturing processes and in our entire line of products. As we work toward our vision of designing for zero waste, we've developed a strategic framework with specific target goals for 2025 We're committed to developing and innovating intelligent products that reduce waste over the lifetime of the appliance, including the use of recycled and recyclable materials. We will endeavor to reduce greenhouse gas by 50% and achieve zero waste to landfill in our global manufacturing operations. We will train 250,000 plumbers, contractors, and technicians on sustainable products, installation, and recycling best practices. Why do I care, Brad? Why does this matter to me? Well, because your customers want to buy products from a company that values sustainability. 84% of customers indicate that they prioritize purchasing a pool heater from a brand that's committed to sustainability. All right, fine. So what can I do? Well, you can let your customers know that environmental factors are important to you in your business dealings. Purchase products and materials from companies that take sustainability seriously. Consider investing in fuel-efficient work vehicles, use paperless billing practices, make sure the appliances you replace are properly recycled. Hey man, you can recycle the cardboard box that the new appliance came in. There are dozens of ways to embrace sustainability in your business, many of which will in fact help your profitability. We just hope you'll take the time to consider them. Write this phone number down. This is the number for our service department. This number is for you, the heater technician. It is not for the homeowner or building manager. Our technical support team will not be able to help them. Issues with a heater that is already installed or being installed will be addressed by technical assistance. For help before installation, ask for applications. The people on the phone don't know what heater you're standing in front of, so you'll need to know the model and serial number. They will also want to know if the installation is indoors or outdoors, natural gas or propane, and the gas pressures and voltages. Be prepared to provide those. When they ask, please give actual numbers. Saying it's good just tells them that you didn't check. They, again, might ask you for voltage or gas pressures at particular specific locations, so be prepared to check. We're glad you chose to sit in on this installation webinar. Don't forget to register for the 3rd class in the Raypak Digital Series, Advanced Troubleshooting. Thanks for choosing Raypak products. Good day.